how long the sun can shine by nuclear fusion by hydrogen. So I guess this is one of the most interesting questions we can solve in astronomy, also even in science. So in the first sentence, about 70% of the total mass of the sun is hydrogen. Among them, only about 10% of the hydrogen is available for the nuclear fusion in the cores. So let's do the suns. Temperature of the sun is the highest at the centers, and it becomes lower and lower in the outer part. So temperature of the envelope, this region, envelope region, is too low to ignite the nuclear fusions. So we cannot use hydrogen as a fuel for the nuclear fusion in the outer regions. Then we only consider the central part. So this means we have a 10% of the hydrogen is available for the nuclear fusion in the cores. So core means this is a core. So we'd like to estimate the total amount of mass of the hydrogen available for the nuclear fusions. So mass of the nuclear fusions can be calculated. Is the mass of the suns 2 times 10 to 30 kilogram. This is mass of the sun. Among them, 0.7 and 70% is the mass fractions of the hydrogens. So mass fraction of the helium is 28% and 2% of the heavy element. So we have to multiply the 0.7 to discover the mass fraction of the hydrogen times 0.1. This is the 10% of the hydrogen is located in the cores. Then you could calculate total amount of the mass, available mass of the hydrogens. It becomes 1.4 times 10 to 29 kilogram. This is the mass of the hydrogen we could use. Then we'd like to discover how much mass is consumed every second in the suns. So we can discover, we have already studied the PP chains. So do you remember the PP chains? So I'd like to only mention the net result of the PP chains. PP chain is 4 protons react to form the helium-4, and plus positrons and neutrino is actually produced at the same time. But in this case, I just skip. And plus energies of the Q. This energy of the Q is derived using the Einstein's famous equation, mc squares. It becomes 26.7 mega electron volt. And then we could find out how many reaction is happening at the centers every second using the luminosity. L is the luminosity. Of the suns and Q. So using the L and Q, L over Q. This is number of reactions. And every reactions, actually proton is removed. 4 proton is removed. So you have to multiply the 4. 4 comes from these numbers. Okay, you have to multiply the 4. And mass of the protons, you have to multiply it. So this is the mass of the proton. this is equal to 1.67 times 10 to minus 27 kilogram. Then you can calculate how much mass is lost, how much mass of the proton is lost every second. So you can substitute luminosity, and Q is 26.7 mega electron volt, and times 4 and the mass of the protons, you can get 6 times 10 to 11th kilogram per second. So this means 600 billion kilogram every second of the 600 billion kilogram of the hydrogen is actually lost at the center of the sun. It's really big numbers. But compared with this mass, still it's much smaller. And then we can use these two results to estimate how long the sun can shine. So available mass is 1.4. Available mass is 1.4 times 10 to 29 kilogram divided by 6 times 10 to 11 kilogram per second. So you can find out the time. And if you actually the kilogram is cancelled out, so this is 2.3 times 10 to 17 second. So you could convert from the second to the years. Then 7 billion years you could find. The sun can shine for 7 billion years. But later, sun loses actually the source of the energy, hydrogen. Then sun cannot keep shining forever. So actually the astronomers can discover the end of the solar system, end of the suns. So this is one of the significant discoveries in the science. And also if you increase the number of the 10%, we assume the 10% of the hydrogen exists in the cores. If you increase to the 30%, of course T is increasing to become the 10 billion years. Sometimes some textbooks said the sun can shine for 10 billion years based on this calculation, 10 billion years. Okay, this is the end of the practice.